Hi, my name's Stuart Lynch. OS 26 introduces concentric rectangle and a corresponding new clip shape modifier. In this video, I'm going to show you how these tools can let you go beyond standard rounded rectangle corners to create unique, fluid, and modern shapes for your SwiftUI views. In this video, we're going to explore one of the new shape APIs introduced in iOS and macOS 26. That's the concentric rectangle and its companion clip shape with the concentric rounded corners. These new APIs give us a lot more creative control when working with rectangles in SwiftUI and clipping shapes. Instead of being limited to sharp corners or uniform corner radii, we can now create rectangles with concentric corner curves that adapt beautifully to their container. And with the new option for clip shape, we can apply the same effect to any view, unlocking some really unique design possibilities. By the end of this video, you'll complete these simple views that will give you all you need to start applying these new APIs to your own projects. If you're enjoying this video, please give it a thumbs up and leave me a comment. And be sure to subscribe to my channel and enable notifications. You can also subscribe to my newsletter that comes out on Wednesdays 2 or 3 times a month. I'll leave a link in the description. The newsletter will tell you about my current and future videos, along with other things that I discover along my coding and personal journey that I think you might find interesting. If you enjoy my content and you want to support my work, you can buy me a coffee. A link's in the description. And if you become a $5 a month monthly member, you can get access to all of my videos, sometimes up to a month before they're released on YouTube. I do have a starter project for the video, and I encourage you to download it from the link in the description. There are 2 branches, and if you want to work along with me, download the starter project branch. You can either clone the repository or download the zipped archive. I do recommend that you work along with me, but if you prefer, you can also download the completed source code from the completed branch. That's up to you. As with all of my starter projects, for the most part, we can do all of our coding and testing in the preview canvas, but I also like to make sure that all of the different views can be experienced while running in a simulator or on a real device. So for this project, I'm again using a tab view with the page tab view style and a menu that will allow me to jump between these pages without displaying the tab view at the bottom of each view. So let's get started on the basics of the concentric corners in SwiftUI and what that means. In this first view, all I have is a Z-stack with a V-stack and a slider within the Z-stack. And I'm doing this so that the slider will be in the center of the view over the V-stack. So in the V-stack, let's start by adding a new container, and it's going to be our concentric rectangle. And it has many initializers, and we'll get to them later. But let's just choose the first one. And since the Z-stack ignores safe areas, it takes over the entire view. So let's add a fill, just like we do for a rectangle. Now, let's add some padding, using the state padding variable as the padding so that we can use the slider to adjust the padding and bring the view more inside of our parent view. As we do adjust the padding now, you'll see that the corners match the corners of our device and adjust to be less and less as you move further away until eventually they're right angle squares. Now, if you want to ensure that you have a minimum corner radius, you can also apply corners argument to the concentric rectangle and choose the concentric case and specify, say, a minimum of 20. So that the corners will start out with the maximum, but will always go down to a minimum corner radius of 20 instead of just a right angle. Let's go back to the original, but we'll leave this in as a comment for reference. Below this, I want to add a regular rectangle shape with a fill of green. But I want to clip its shape to a new rect modifier that allows us to specify the corners as being concentric. And I'll add some padding with the slider padding. Now, as I adjust the padding, you'll notice that the lower corners of the red and the upper corners of the green are no longer concentric, and that's because they are not near the corners of the view, so they are right angles. Well, I find this syntax here a bit verbose, So instead of using this rect modifier, I'm simply going to use the concentric rectangle as the clip shape. You'll get exactly the same thing. Well, if you don't want all 4 corners to be concentric, you can make them uniform by adding 2 additional arguments for the concentric rectangle. And that's the corners argument with a isUniform Boolean, which defaults actually to false. So the corners are going to be concentric, but we'll make the isUniform true. Now the green rectangle has those concentric corners all around. Now you may be wondering why we would ever use a rectangle with a fill and a clip shape when our concentric rectangle does exactly the same thing. Well, you wouldn't, and you'd be right. But the clip shape can apply to other views as well, like a color. So I'm going to replace this rectangle here simply with a color of green. And that's a view, and I'm just going to leave the clip shape the same. So it looks like we've got the same result here. We have already seen how, by default, the corners of the concentric rectangle are not uniform. We have total control, though, over every corner. In this next view, let's explore that. In the VStack, let's add a concentric rectangle, and I'm going to choose the initializer that lets us specify every single corner individually. We can set the top leading corner to be 0, so it'll always be a right angle. The top trailing, say, to be 50. And then the bottom leading to be concentric, but the bottom trailing to be concentric, but with a minimum of 12. And let me add a mint gradient fill. And I'll apply the padding bound to our slider padding. Now initially, with no padding, and because we are ignoring the safe areas, all of our corners are less than the corner radius of the view. As we slide the slider, though, we see that the top leading is always a right angle, while the top trailing is always 50. And the bottom leading is concentric until it gets too far away, where it becomes a right angle, while the bottom trailing is concentric, but it never goes below a corner radius of 12. Below this one, let's create a red color view and apply a clip shape. That will be our concentric rectangle shape. But again, I'm going to choose one of the other initializers. And for this one, I'm going to choose a uniform top corners, but specify to choose just bottom leading and bottom trailing. So for the top corners, I'm going to make them both concentric, but I'll choose a minimum of 20. For the bottom leading, I'll make it fully concentric. And for the bottom trailing, I'm going to choose a fixed radius of 100. And again, I'll add some padding bound to our sliders padding. As we adjust the slider, we can see how our corners adjust as specified. You could get pretty creative here, but there's more. Well, we don't always want our views to consume the entire view. So what we can do is we can specify a container shape of any size. So in this view, I've got 2 sliders, one for padding and another for a container radius. So let's use both of these state properties in our first view in our VStack. So I'm going to create a concentric rectangle as I did previously. I'll apply a fill of a red gradient. The padding is going to be bound to our padding state variable slider, but I'm going to set a frame to a height of 200. And then I'm going to apply a background of black, and then I'm going to apply some padding to bring that whole thing in from the sides of the view. Now you'll notice that this just looks like a regular rectangle. The corners are not at all concentric looking because the rectangle is far away from its parent view's corners. Well, what we can do though is apply another modifier that will allow us to specify the container shape for the concentric rectangle. And we can specify what we want to be as a rounded rectangle. So we'll use a rect static modifier method with a corner radius bound to our slider's container radius. Now, since the container radius starts at 0, we see no change. But as we adjust it, we can see that the container and its background adjust to the rounded rectangle. And if we apply more padding, we can see that the concentric rectangle adjusts accordingly here too. For the second view though, let me change this to be a clipped color instead of a rectangle. We'll start with cyan as the color. And then I'm going to apply a clip shape of a concentric rectangle. Then I'll add some padding bound to our padding slider again. And again, I'm going to set the frame to a height of 200. And apply a background of black. And then I'm going to add padding here to move this in from the side of our view. Now, until I apply a container shape, though, it still looks like a rectangle. So this time, though, I want to choose a capsule as the shape. Now the container radius doesn't apply here, but I can adjust the padding slider, and you can see that our color view adjusts to the corners of its capsule the whole way. Natalia Pamfirova has a great blog post on concentric corners, and I'll leave a link in the description. In this post, she talks about how you can use concentric rectangle containers within modal sheets or popovers. So I want to take a look at what that looks like. In this view, I have two Boolean state properties, one for show sheet and one for show popover. And there's a text view with an on-tap gesture that toggles show popover and a toolbar button that will toggle show sheet. So let's create a modifier that will show the sheet first, where isPresented is going to be bound to the show sheet variable. For the presented sheet, I'm just going to create a concentric rectangle with a fill that is a blue gradient. And I want to add some padding to move it in from the actually presented sheet. And I'm just going to ignore any safe areas. I'm also going to specify a presentation detent, and I'm just going to enable the medium case, so it's never going to go to the top of the view. Now when I tap on the Show Sheet toolbar item, the sheet's presented, and since it has corners along the top edge and the bottom edge is adjacent to the device edge, our concentric rectangle is conforming to the concentric corners here as well. Perfect. Now let's also present a popover for our text view that has that on-tap gesture associated with it. So like the sheet, we can use an isPresented for a popover and bind it to the show popover Boolean state property. For the content this time, I'm just going to use a yellow color view, but I will clip it using a clip shape of a concentric rectangle. I'll bring it in from the side by adding some padding, and I'll set a frame to be 200 by 200. Then to ensure that it'll actually pop over when we have a compact screen like we have here, I'm going to apply a presentation compact adaptation of the popover case. Now when I tap, I get the popover, but there is an issue here that Natalia pointed out. The bottom corners are not actually concentric. To solve this though, we can add a corners and isUniform argument to our concentric rectangle. And we can specify that the corners are concentric, but we'll have to indicate that isUniform is true. Now it works. In the assets folder, I have uploaded 4 of my photos, and all 4 of them have the same dimensions. Now I want to lay these out in my view inside a container that has rounded corners, and I'm going to use a V stack and an H stack to do that. Now I have a slider here that is bound to a spacing property that is used for the VStack that I have here already. So let's just first create a single image right now in the VStack, and I'll use one of my assets like the Lahaina shot here. And we'll make it resizable and scale to fit. And then I'll apply a clip shape that is a concentric rectangle. And since we're not ignoring safe areas, the corners are not rounded because I'm too far away from the edge. I can, however, embed the VStack in a container shape that is a rounded rectangle, and we can specify a corner radius of whatever we want, like 60. So let's embed this image here in an H-stack, and I'm going to use the same spacing. And I'm going to just copy this image and its properties for the second item, but I'll change the asset to be the city asset. Notice how the outside corners are now rounded, and I can adjust the spacing and see how my image looks. Only the outside corners are rounded. This is nice. So let me copy this H-stack and add it as a second element of our V-stack. And I'll change the assets to my other two images, the petals and the stream. And I can adjust the spacing, and it kind of gives me a nice look. Just the outside corners again are rounded. Well, what happens if I add one more row? So let me just copy that first H-stack, and I'll use it too. As I adjust the spacing, you can see that the center image corners are not affected at all because they are nowhere near the top or bottom edges of the rounded rectangle. Now there's one more thing that I thought I'd share. I want to take a single image, either from my asset folder or from a URL, and split it up into a grid within the container with rounded corners. And I want to be able to specify what my rows and column numbers are going to be. So I have in this bonus folder provided you with a tiled image view that I created that's going to allow you to specify either that image as a resource or as a URL, and the number of rows and columns for a grid, and a spacing that's going to default at 10. And that will split up that image into an array and display it in the grid. Let me show you how this can be used. So in my final view here inside the scroll view, there's some padding here. So let's create a tile image using the resource initializer. And I'll specify petals as the resource with 2 rows and 2 columns. Now the default spacing is applied, but I want to reduce that to, let's say, 5. Well, how about a second one using a URL? And for the URL, I'm going to use an image from the Pixum Photos random photo generator. So I can create that URL with a URL string and specify the Pixum site, that is pixum.photos, and then indicate that I want one that is 200 by 300. So I can then use this URL in the other initializer and say that I want 7 rows by 4 columns. Well, I can see that URL can't be optional, so let me force unwrap it at the source and refresh the preview. I can now see my 2 images in the scroll view, but I really want them to have rounded corners at the edges of my grid. And that was the whole purpose of this video. So all I have to do is to go back to my tile image view where I've created that grid and apply a clip shape of concentric rectangle to my lazy V grid. And then specify that I want that to be in a container shape that is actually a rounded rectangle with a corner radius of, say, 40. So if I switch back to my tile image view now, I can see that my petals has rounded corners, and as it fetches a new random image from the Pixum image generator, it too has rounded corners. And I could adjust my rows and columns and even my spacer to get a nice effect. Well, that's it for this video. So I hope you've learned something here that you might want to use in your own projects going forward. Thanks for watching. If you found this tutorial helpful, please give it a thumbs up and leave me a comment. You can subscribe to my channel to get notifications of new videos. And remember that you can also download my YouTube channel listing app for free and quick access to all of my 350 plus YouTube videos. A link's in the description.